Hello. Today we'll be showing you how to tap into the power of BigQuery's external data sources and Omni features through a manageable, hands-on BigLake example. Thanks to these data federation capabilities, we'll be able to access a broad range of storage services, even those that are part of rival clouds and non-Google Cloud storage systems. While there are many relational databases, NoSQL databases, and flat file options, today's focus will be on Google's cloud storage as an insightful and representative example. To kick things off, let's navigate to the BigQuery page in our Google Cloud Console. Here, we'll create a new dataset for our example and use the query editor to create an external table specification. Interestingly, there's more than one way to achieve data federation with Google Cloud Storage. All these methods are found in the Google Cloud documentation. However, our video today will be centered on the recommended BigLake approach for querying our data in cloud storage. What separates the BigLake approach is its use of a connection asset to query cloud storage data. This connection gives us a dedicated service account and the possibility of granting access in a more controlled and granular way. We do, however, have a more simplified version of the BigLake approach. Here, you'll encounter more broadly defined permissions, since the same IAM principle handles both our BigQuery query and the cloud storage access. Last but not least, we have the Cloud Storage Object Tables approach, which provides metadata about the cloud storage objects, not the data inside them. This often comes in handy when paired with other cloud storage data federation mechanisms like the BigLake tables. Today, we'll narrow our attention to BigLake tables, since the simpler external tables approach is typically not advised, and the object tables approach is only for unusual use cases. With that out of the way, let's go ahead and create our connection. We'll choose the BigLake connection type after enabling the API. Once we've provisioned our connector, we will find a key detail, the service account ID, adding an extra control layer over the IAM permissioning. We recommend jotting down this service account ID for use in the next setup step. Next up, we'll set up our Google Cloud Storage bucket and give permissions to the freshly created service account. As we create our cloud storage bucket, we'll go with the default configuration options. In this Google Cloud bucket, we're going to upload an example CSV file. You'll find the CSV file and our diagram file in the video description for your reference and reuse. Before leaving our cloud storage page, let's grant access to our BigQuery connection by adding the permission previously discussed. We'll utilize the earlier service account ID as the principal and assign it the object viewer role. Having accomplished that, let's switch back to BigQuery to set up our external table within our example dataset and by using our connector. In the SQL query editor, let's paste in a templated example for creating the external table. We'll start populating some key values here. Keep in mind that you have control over the data's staleness and caching for performance, though we won't use any form of caching in this instance, an approach that avoids stale data, but at the expense of performance. As for the max downtime configuration, considering its default is 0, we can skip over this setting. Once that's done, let's proceed to create our table. Now, if we navigate to the table, you'll notice that it automatically identifies our schema. You also can see the external data configuration in the Details pane and a BigLake table tag near the top of the pane. Like our other tables, we can easily query and analyze this data. Remember, we're not initiating any copy operations here. Instead, we're accessing the Google Cloud Storage data in place. Please leave your questions in the comment section below. Thank you for tuning in, and please enjoy responsibly.